Hey students, we are doing paper 4 of 2025, the latest paper 2025, February, March, and we have attempted the first 3 questions in my first video, and now we are doing question number 4, 5, and 6 in this video. I linked my first video in the box, so you can go through it. Okay, now question number 4 is carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. So this is a reaction, carbon monoxide plus chlorine gives carbonyl chloride, COCl2, and the delta H is given, which is minus 105 kilojoules per mole. The process takes place in a closed system and an equilibrium is reached. The conditions for this process are 200 degrees Celsius and 2000 kilopascal. Explain what is meant by the term closed system. Now, the closed system is when a system is closed from all the sides and nothing can enter or leave the system so that it can attain equilibrium. So our answer will be when no reactants and products can leave the system. Can leave or enter. Describe what the symbol delta H means. Now delta H means enthalpy change. You have to write the change also because the symbol delta means change. So write enthalpy change full. State how the value of delta H shows that the forward reaction is exothermic. Very clear because the exothermic value here, the value is negative. The value is negative, which means that the forward reaction is exothermic. Deduce the value of delta H for the reverse reaction. Include a sign in your answer. Now, if the forward reaction is minus 105, then the backward reaction will be positive 105 because the reaction is in equilibrium. So the reactants and products are forming at the same speed and they have the same concentration also. They're in equilibrium. So if the forward is positive, then the backward will be forward will be negative, then the backward is positive. So it will be positive 105 kilojoules per mole. Complete the table to show the effect, if any, on the concentration of carbonyl chloride at the equilibrium when the following changes to the conditions are applied. Okay, now we have to use these words increase, decrease, or no change. That what will happen to the concentration of carbonyl chloride. This is the equation. For simplicity, let's write the equation down. It will be CO. It is CO plus Cl2 gives COCl2. This is the equation. All of them are gases and no balancing. The forward reaction is exothermic, minus 105 kilojoules per mole. Now, to see the COCl2, we have to see that if the reaction is moving forward or backward. So if the temperature is increased, the system will always do the opposite of whatever change is done. So if the temperature is increased, the system will move towards the endothermic side where the temperature is less. So here, if the forward reaction is exothermic, we can see from the delta H, the forward reaction is minus 105, then the backward reaction will be endo. So by increasing the temperature, the system will move backwards and the concentration of carbonyl chloride will decrease. Then some carbon monoxide is added. When some of the carbon monoxide is added, then system will move towards the side where there is no carbonyl chloride formed. So obviously, again, the system will move backward when no carbonyl, so system will move forward because in forward direction, there is no carbon monoxide forming. When we add some carbon monoxide, system will move where there is no carbon monoxide. And on the product side, there is no carbon monoxide forming. System will move forward and hence the concentration of carbonyl chloride will increase. Okay. Now, when the pressure is increased, if the pressure is increased, then system will move towards the side where we have fewer number of moles, where we have less number of moles. And the less number of moles are on the product side. As you can see very clearly here, that on the reactant side, we have one total 2, and on the product side, we have just 1 number of mole. So if the pressure is increased, then system will move towards the fewer mole side, towards the forward side, and the concentration of carbonyl chloride will increase. And as for the catalyst has no effect, no change on the position of equilibrium. It only affects the rate. Next question is, the equation for the reaction can be represented as shown. So this is the equation. The same equation, carbon monoxide gives chlorine. Carbon monoxide is reacting with chlorine to form carbonyl chloride, and the delta H is minus 105. And the bond energies are also given to us. Use the bond energies in table 4.2 and the value of delta H for the reaction to calculate the bond energy in kilojoules per mole of the CO bond. So we have to find the delta H, where we have to find the bond energy of the CO bond by calculating the reactants, products, and considering the delta H value also. So let's calculate it. First of all, we will calculate the energy needed to break the bonds in the reactants. Now, in the reactants, we have one CO bond. There is just one CO bond. And there is one chlorine bond. Plus, there is one Cl-Cl bond. We'll substitute the values. C triple bond O is 1075 and chlorine is 240, which makes it 1315. For the next section, calculate the energy released when the bonds in carbonyl chloride form. So we have to calculate the energy released in carbonyl chloride. So in carbonyl chloride, as you can see, there is two Cl bonds, two CCl bonds, and one CO bond. So here we have two CCl bonds, okay? And two CCl bonds, we'll consider it in the product in the next section. We have CCl. This 2CCl will, and there is one CO bond. This whole thing is used to calculate the bond energy of CO. So we will use it in the next section. Here what we'll do, in this section, we have the reactants energy, which is 1315 and minus X, which is the product. So we will do the reactant minus product and it gives us delta H. So reactant is 1315 minus product is X. Delta H is minus 105. Is minus 105. So we'll take this 1315 on the other side. So it will be minus 1015 minus 1315. We'll calculate it and the answer comes out to be 1420. So this is the answer, 1420 of the second section. Now in the third section, we have to consider this thing, which I wrote above. We have two CCl bond and CCl energy is 340. So we'll do 2 into 340 plus C double bond O, which we don't know, is equal to 1420. So here, 2 into 340, which is 680 plus C double bond O, 1420. We'll take it on the other side. 1420 minus 680. And the answer comes out 740 kilojoules per mole. So that's the solution. That's how you will find out the bond energy of any substance. First, in the second portion, you will calculate the delta H, and then you will calculate the bond energy of whatever substances, whatever bond is required. Then we have to complete the dot and cross diagram for this carbonyl chloride. Now, carbonyl chloride is, the structure is like this, that carbon is bonded with two chlorine atoms with a single bond and double bond with one oxygen. So we'll make it, carbon has 4 electrons in its outer shell. So it will share 1 electron with 1 chlorine and 2 electrons with the oxygen. That's carbon. And as for the chlorine atomic number is 17. So its configuration is 2877 electrons. So it will share 1 electron and rest of the 6 electrons will be made outside. They will form lone pairs. And same with the other chlorine also. And for the oxygen atomic number is 8. 2 and 6 is this configuration. So it has total 6 electrons. Out of 6 electrons, it will share 2 electrons with carbon and rest of the 4 electrons will be drawn outside. So that's how the carbonyl chloride dot and cross diagram will be made. Okay, now next question is manganese is the element with atomic number 25 and calcium is the element with the atomic number 20 in the periodic table. Now we have to complete the table to show the number of protons, neutrons, and electrons in manganese atom and calcium ion. So as manganese atomic number is mentioned in the question, it's 25. So 25 proton. Its electrons are also 25. And as for the neutrons, we'll do 55 minus 25. So 55 minus 25, it comes out to be 30. For calcium, the atomic number is 20. So its protons are 20. Electrons will be 2. It has lost 2 electrons. So 18. And for the neutrons, we'll do 42 minus 20, which comes out to be 22. Next, manganese forms several oxides. The formula of some of the oxides are shown. Suggest why manganese is expected to form colored oxides. Very simple. Manganese form colored oxides because it's a transition element. State which other property of manganese is shown by the formation of several oxides. Now, manganese is forming several oxides. Different means it forms the oxide, the same compound oxide with different oxidation states. Because its oxidation state is different, that's why it can form different compounds with the same element. It has variable oxidation state. So we can write here that it forms variable oxidation state. State the formula of manganese oxide. Manganese 2 oxide. Now for manganese 2 oxide, manganese 2 means that its valency, its oxidation state is +2 here. And oxide ion is always 2 minus. When both charges are equal and opposite, they cancel each other out and the formula becomes simple MnO without any number. Mn2O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as a reducing agent. Define the term reducing agent. Now, reducing agent, reduction, if we talk about reduction is the removal of oxygen. It's the removal of oxygen and the addition of electrons. Addition of electrons. So it means that reducing agent is the one which removes oxygen from the other substance, which removes oxygen from other substance. Or you can also write is that it is a substance which adds electron or electrons to the other substance. So because they're asking about the general, they're asking the general question, so you can write it generally, that it reduces the other substance. How it reduces? By removing oxygen from the other substance or by adding electron into the other substance. Okay. And after this, you have to mention that and itself gets oxidized. Because this question is of 2 marks. So first mark is for writing that what it does with the other substance, and the second mark is what it does to itself. So it reduces the other substance, but itself gets oxidized. Complete the symbol equation by inserting the formula of the missing product and balancing the equation. So manganese oxide plus aluminium, as aluminium is more reactive, so it will displace manganese and form aluminium oxide, Al2O3. And if we balance it, then here we have 4 oxygen atoms, and on the product side, 3 oxygen atoms. So we'll write 4 here and 3 here to make oxygen 12 on both sides. And then we can balance the manganese, which is 9. So we'll write 9 here. And on the product side, aluminium is 8. So we'll write 8 here. Next, manganese oxide reacts with dilute hydrochloric acid as shown. So we have manganese oxide plus HCl gives manganese chloride plus H2O plus chlorine. Calculate the volume of chlorine. We have to calculate the volume of chlorine gas. This one, calculate the volume. And we have some information about HCl given. Its volume and concentration is given to us. And we'll find out, from HCl, we'll find out chlorine. And in the middle, we'll find the moles of both. Calculate the number of moles of HCl first. We'll use the formula here. Moles is equal to volume into concentration divided by 1000. Volume value is 50. Concentration is 0.2 divided by 1000. The answer is 0.01. Now determine the number of chlorine formed from the moles. If we have the moles of one substance and we want to find the moles of the other substance, then we will always take ratio between them. So we'll take the ratio between HCl and chlorine, number of moles. First, we'll see their ratio from the equation. In equation, the HCl is 4 and chlorine is 1. So in the balanced chemical equation, the ratio is 4:1. So if 4 is giving 1, then 0.01 will give how much? We'll do the cross multiplication. It will be 0.01 divided by 4, comes out to be 0.0025. Now to calculate the volume of chlorine, as chlorine is a gas, so we'll use the formula moles is equal to volume over molar volume. Volume over molar volume. The number of moles of chlorine are 0.0025. Volume we need to find, and the value for molar volume is fixed, which is 24 if it is in decimeter cube and 24,000 if it is in centimeter cube. So this value is fixed. the volume present in 1 mole of every substance is 24 or 24,000. Here we have to find out the answer in centimeter cube. So we'll use the value 24,000. We'll take it here, multiply, and the answer comes out to be 60. Describe a test for chlorine gas. As we know that chlorine gas is acidic and it is a bleaching agent also. So we'll use damp red litmus paper. Damp red litmus paper. And the observation will be it bleaches out or it becomes white. Then explain in terms of collision theory why decreasing the temperature decreases the rate of reaction. We know that temperature and rate of reaction has a direct relation with each other. So when temperature is decreased, the rate of reaction will also decrease. But why? We have to explain it in terms of collision theory. So what we'll write first, that as the temperature is decreased, the kinetic energy of the particles decreases because temperature directly affects the kinetic energy of the particles. Particles decreases, kinetic energy of the particle decreases, movement slows down, and the particles collide less often. Their energy becomes less than the activation energy. Energy becomes less than the activation energy, less chances of effective collision, and product will form at slower rate. So this is the whole answer. These are these specific words which you have to use in this question. In this type of question of rate of reaction in which they ask you to explain in terms of collision theory, you have to use these keywords. Like first of all, you will write that the temperature effect directly affects which thing. So if it is temperature, then it directly affects the kinetic energy of the particles. Then you have to write about the movement. Then collision being less often or more often or frequent. You can also use the word frequent here. Then you have to write that the energy becomes greater than or less than activation energy, more chances or less chances of effective collisions, and the product will form at slower rate or faster rate. So these are the things which you need to write in your answer. Next question, the structural formula of two compounds A and B are shown. A and B are members of the same homologous series. Give two reasons why a structural formula of A and B show that they are members of same homologous series. Now, they are the member of same homologous series because of the same functional group, which is double bond. Same functional group. The double bond is the functional group and it is the same in both of them. The second thing is they both follow the same general formula. They both have the same general formula, which is CnH2n. Because they are alkenes, and alkenes will form CnH2n, will follow CnH2n general formula. So it's the same in both. Explain why A and B are both hydrocarbons. Because they contain only carbon and hydrogen atoms. Write the symbol equation for the complete combustion of A. Now for the complete combustion of A is C3H6, C3H6, plus O2 gives CO2 plus H2O. This is the complete combustion, and now we'll balance it. For carbon 3, 3, and for hydrogen 6, we'll write 3 here. Now this makes oxygen 6 and 3 total 9. 9 oxygen atoms. So to balance 9, we'll balance it with 4.5 here, 4.5 into 2, which makes it 9. Now, as we cannot balance in the decimal, so we have to multiply this whole equation with 2 to turn it into a whole number. So if we make it in the whole number, then if we multiply it with 2, then this propene will become 2, oxygen will become 9, carbon dioxide will become 6, and water will also become 6. Now we'll balance it. We'll write these numbers: 2, 9, 6, and this is balanced. Deduce the empirical formula of A. Now A is C3H6. We'll cancel it because empirical formula is the simplest formula. So we'll divide it by the table of 3. So it will become CH2O. Name compound B. The compound B is 4 carbon with a double bond present between carbon number 2 and 3. So it will be butene because there are 4 carbons. So it will be but. 4 carbon is but, and on the second carbon, the double bond is attached. So it will be butene. The structural isomer of B is a member of same homologous series. Draw the displayed formula of this structural isomer. So we'll draw the displayed formula of the structural isomer. So it is butene. So its isomer will be but1ene. So we'll draw 1, 2, 3, 4, 4 carbon. We connect them with each other. There is a double bond between carbon number 1 and 2, like this. So here we'll complete it with hydrogen, 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 and it will become, it is but2ene, but1ene. Compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown. State why this is an addition reaction. In addition reaction, there is only one product. So this is an addition reaction because there is only one product formed. Describe the color change in aqueous bromine during this reaction. Okay, now aqueous bromine is brown in color. Aqueous bromine is brown. And when it reacts with any alkene, then alkene reacts with it. The bromine, the brown color is because of bromine molecule. And when bromine molecule breaks, the brown color fades out. So it becomes brown to colorless. Name the product C. Now, in product C, we have, first we'll count the number of carbon atoms. 1, 2, 3, 4. So it means it's but. Then we have 2 functional groups, bromine, dibromo, and 2 bromine atoms are attached on carbon number 2 and 3. So the name will be 2, 3, dibromo, butane. Under certain conditions, 1 mole of B reacts with oxygen to form 2 molecules of carboxylic acid D. Carboxylic acid D has 2 carbon atoms. Okay, draw the displayed formula of carboxylic acid D. Now it contains only 2 carbon atoms and a carboxylic acid group. So we have 2 carbons, and on 1 carbon we can draw the carboxylic acid group, which is double bond O and OH, and then we can attach the rest of them and complete the valency with hydrogen. Name the carboxylic acid D. So carboxylic acid D is ethanoic acid. Complete the symbol equation for this reaction. Now what's the reaction? 1 mole of B reacts with oxygen. It reacts with oxygen to form 2 moles of carboxylic acid. So it reacts with oxygen O2 to give CH3COOH and 2 moles of CH3COOH. So oxygen moles are also, will be 2. So this is the last question. We did the last 4 questions in this paper, and for the first 3 questions, you have to see the previous video to go through the first 3 questions, and the paper is done.